Hello, everyone. Let's continue with the matrix algebra. And as we reviewed last time, we know how to find the eigenvalue, how to do the transpose and do the matrix multiplication between the vectors and to validate the sum of the uh, basic concept such as the eigenvalue and the eigenvectors. So in the next example, it has the very kind of a advanced techniques to show you how to decompose a matrix. And we see this is a small example, but it's conceptually it is a very helpful to understand this. Let's find the eigenvalues of the matrix A, and the also the eigenvectors of the matrix A. This kind of will give you some validation to verify what it is supposed to do. So as we can see in this step, and it will reconstruct back to the original matrix as we see using the eigenvalue and the eigenvectors. We can compare the matrix AA and then the original matrix and the A. As we can see, they're fairly close, or they're exactly the same as we can see. That's the purpose of the example, and a fairly important concept. Well, 11, number 11, for this example, it will try to give you some of the different formats when you do the matrix manipulation. It's a fairly straightforward, but we can run this through fairly quickly. And in this example, the next example, so we will see how certain operations can be done in R, like a cross product. In some of the calculations or the statistical analysis, like a sample line, um, linear regression, or the other principal component analysis, you may use this very often trying to figure out how to solve the problem. Here, this is to show you the low dimension matrix to illustrate the concept of this. Well, there is another very important concept about the covariance. So how to form the covariance matrix from the different dimensions of the data set. Typically will be a structured data set. Let's just find out from this example, and we just run a cross product. And this is a very short example, and then you can find that um, sigma at a different position in the matrix is only 2 by 2 matrix here. It's a very small, but it will give you some important concept verified here. So, oh, it is 3, yes, but that's the unique values it's just showing here. Well, the next example also relate to the covariances. Let's run this fairly quickly. Diagonal is defined as a diagonal. That means um, the I equals G when we run this program. If you want to program it by yourself, squared we have well, a correlation matrix, and then and you can find out by the the a few steps here. Well, let's just stop here for this. Actually, there are a lot in this short video. This is to give you a reference, and you can room in and even find the other materials online to read before you do a little bit exercise by yourself. Thank you for watching this video.